All right, these are the answers to the test review for the statistics test. First questions ask us to see if these are statistical questions and give a reason. Remember, with statistical questions, we have to be able to collect data. That data has to vary from person to person, so meaning more than one person has to be in mind here, and we have to have a specific population. Who are we talking about? So how many letters in my last name? I can give you that answer, but it would just be one answer. It wouldn't vary. So this is no, it doesn't vary. Or just population's only one. We need more than one person. What are the colors of shoes worn by students in my school? Now I could collect data. That data would vary. I have a population in mind, the students in my school, so I'd say yes, this one will work for sure. This asks us to rewrite these so they are statistical. How much did I spend at the mall this week? We could say simply, how much do I typically spend? Typically spend in a week at the mall. All right, or online, or however we want to update this question. But the idea being that now we're going to look at several weeks instead of just 1 week. All right, and that'll make it vary. How tall is my teacher? How about how tall are the teachers at my school? So your teacher's just one person. Now we've included more than just that one person. Okay. And then categorical, numerical. Remember, again, numerical means you're going to get a number for your answer. So the names of the adults and my aunts and uncles, those are not going to be numbers. I'm assuming they're just names. That's going to be a category. The amount of credit card bills the last 6 months. All right, well, that amount would be some kind of number. So numerical. All right, pretty straightforward. Second page here gives us a dot plot, and for 12 different games, this is how many goals were scored by the soccer team. So what number of goals describes the center of the data just by visually estimating. So you're just kind of looking and you're saying, where would I think the center would be? So we've got, like 7 dots over here and 5 dots here, but these dots are kind of over there. If I had to put a center, like a balancing point, I'd say somewhere between 6 and 7. And again, this is just kind of rough estimate, somewhere in the middle of those dots, right? Wouldn't want it to be back here, wouldn't want it to be up there, somewhere in the middle. What is the median? Now let's go ahead and find out what the middle of this is. So if you come to the middle of your dots, where you're gonna end up is between 4 and 5. So we'd say 4.5 is the median. 6 of the dots are before that, 6 of the dots are after that, so 4.5 will be our median. What is the range of goals scored? Well, we scored anywhere from 13 to 1, so 13 minus 1 gives us a range of 12 goals. Just high minus low. Describe the shape of the distribution. If you look at this, it goes up and then tails to the right. So we would say this is skewed right. And then calculate the mean. So what we want to do is add up the total number of goals scored. So 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 7, 7, 10, 12, 13. That'll give you a total of 73 goals scored in 12 games. If you divide that, we get 6.08. So about 6 goals a game is what was being scored. We thought the middle was around 6 or 7. We get 6, so that should check out for us there. 12 and 13, some years we may skip this, but just in case this is on your test, we'll go through this here. So she wants to earn an 88% for 6 quizzes. She has 1 left to take, and we've got a list of 5. So first off, we're gonna figure out what her total is, all right? So for her total number of points, 6 quizzes times an average of 88 per quiz, 6 times 88, gives us 528 points that she needs altogether. If she scores that many points, then she'll end up with an average of 88. Now, she's already scored these number of points. So what we're gonna do is take 528, and we're gonna subtract away what she's already scored. So she's already scored a 74, so minus 74, minus 92, minus 83, minus 98, minus 100. And that means minus what she's gotten, what she has already scored, left us with 81. That's what she needs. She needs an 81 or higher in order to get the average that she wants. All right. So Frank here wants a bowling average of 215 for 8 games. All right. So same idea. We're going to go 215 times 8. So he needs a total score of 1,720. Okay. But he's already scored these other ones. So we're going to minus what he scored already. So if I go minus 159, minus 182, minus 225, minus 240, minus 198, minus 200, minus 230, that means he has to score a 286, a high score. Still possible, but it's going to be tough, right? Not an easy one. Again, these may not be on your test the year you take it, but just in case, there they are. All right, 14 says, if data set A has a standard deviation of 15 and B has one of 5, can we draw a dot plot, whatever that would do it? So we'll start with the dot plots, okay? Here's A, here's B. So A has a higher standard deviation, so that means its data is more spread out, whereas B would be closer together. So more spread out versus close together. Higher standard deviation, lower standard deviation. All right. Box plot. We have a box plot where everything is kind of stretched out for A versus B where everything is pretty compact. Okay. High standard deviation, low standard deviation. Right. Histogram, similar. For A, everything is kind of stretched out. Sorry that this one's leaning over, all right? But you see how these are all stretched out over here versus B where most of them pretty close together, all right? So high standard deviation, spread out data. Low standard deviation, data's right there together, all right? So here's a histogram, and they say how many people between 20 and 30 went to this festival. Here's 20 and 30, it looks like about 20. You said 21 or 19, it's whatever. It's right in that area. How many 34-year-olds were there? Now, the 34-year-olds would be in this category, but I don't know what any of these particular ages are. I just know they're between 30 and 40, so we don't know. All right. We know it had to be less than 40 or around, because the height of this is at 40. So couldn't be more than 40, but how many, and specifically, we don't know. How many under 30 went? So here's 30, and we had about 20 there, and then about another 25, so maybe 45 under the age of 30. It's these two put together. All right. How would you describe the shape of this distribution? So it kind of has a little bit of a mound shape to it. I would say mound. If you thought it was uniform because they're pretty close together, I could see that too, but mound's probably a little better. And would you say this has a high standard deviation or a low one? Now, again, our middle is right here. Most of our data is kind of compacted in there. I think it just kind of depends on whether you think this is kind of far out or not. I would say for this one, it's probably a low one. Most data is close to the middle. We don't really have a bunch that are far, far away from the middle there. That would be my guess. All right. All right, then we're asked to make a box plot for this data. Now, the first thing you had to do is put all the numbers in order, so I already did that to save us a little bit of time. Our minimum number is 24, our maximum is 66. All right, if we go to the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here is the middle, 10 on this side, 10 on that side. The middle is 42, so our median is 42. All right. Then 1, 2, 3, 4, 5. Here's the middle of the low end, right between 32 and 33, so 32.5, and then 1, 2, 3, 4, 5, right there. There's the middle of the high end, so that's 45. All right. Our interquartile range is Q3 minus Q1, 45 minus 32.5, which gives us 12.5. Okay. and then create a box plot for this data. So we're gonna start here, 20, 25, 30, 35, 40, I might have messed up. Let's see, 55, 60, we're gonna just barely get it on there. Okay, so 24 is our minimum. We're gonna put a line at about 24 there. 32 and a half is right about right there. 42, right there. 45, pretty close, and then 66 is way out here. All right, make the box in the middle part, and then draw your line out here and here. So there's our box plot for that data set. All right, then we get 2 box plots that are 2 different batteries, brand X and brand Y. Each part is 25% of the data. So 25% of brand X is here, 25% here, 25% here, 25% here. Okay, the best battery it has is right there. Brand Y, 25% of its batteries are in this range, 25% here, 25% here, 25% here. All right, so we're asking true-false questions first. 50% of the time, brand X has less than 13 hours of battery. So if you go right to the middle, and it's right at 13, half of those batteries, 50% of them, were less than 13. This is true. We can see that right there, 13, half of them were below that. Every battery of brand Y lasts longer than every battery of brand X. Well, we see that's not true. We've got a whole bunch of brand Y batteries right in here that are less than that one. So that's a false one. Okay. Brand Y lasts 15 hours or more 75% of the time. So 25, 25, 25, 75% of them are 15 or above. That is true. We know that at least one battery of brand X lasted exactly 12 hours. Now this is kind of a sneaky one. There is a line, it looks like right on 12, but that Q1 doesn't necessarily have to be an exact thing, right? Like the box plot we just did, we found Q1 to be in between and stuff. So this one is not necessarily true. I would say this is false. It probably is true, but we can't prove that. We can't say that for sure. The best battery of brand X is at the 50% level of brand Y. The best battery of brand X, which is right there, is at the 50% of brand Y. That's true. Which means half of the brand Y batteries last longer than the best battery of brand X. Right? The middle 50% of brand Y batteries last between 15 and 17 hours. The middle 50% last between 15 and 17. That is true. That's exactly what that's saying. The standard deviation of brand X is bigger than the standard deviation of brand Y. So a bigger standard deviation means you're more spread out. Let's see how brand Y is more spread out than brand X. Brand Y would have the higher standard deviation. So this is a false statement. It'd be the other way around. And then 75% of brand Y batteries last longer than 75% of brand X batteries. So 75% of brand Y batteries last longer than 75% brand X. That appears to be true as well. All right, then we've got our two-way table. This one gives us 2 different counties. You can be in Milwaukee County or some other one. And we ask them, have you been to the Dells or no? So what's the probability that someone's from Milwaukee County and has not been to the Dells? So Milwaukee County, not to the Dells. That was 45 people out of the 465 that are there. We could divide that and get a percentage if we want, but that's the probability. What's the probability that someone's been to the Dells but does not live in Milwaukee County? Has been to the Dells but not from Milwaukee County. That's this 140 out of the 465 people. Okay. What is the probability someone lives in Milwaukee County? So Milwaukee County, that's 245 out of the 465. Okay, so all of those are out of those totals. Now 27, knowing that someone has been to the Dells, what's the probability they do not live in Milwaukee County? Knowing that they've been to the Dells. So we're looking just right here at this column, these 340 people. What's the chance that they don't live? That'd be 140. So 140 out of 340. Okay. And knowing that someone lived in Milwaukee County. So now we're looking at the Milwaukee County people. What's the probability that they've never been to the Dells? So that would be 45 out of the 245. 45 out of 245. Then our last one here gives us a partially completed, and we're supposed to try to fill in the rest. So we're 450 people here, 340 of them have taken a selfie next to the Crusher statue. If we go 450 minus 340, that's 110 who have not. Of these 110 who have not, 25 were from South Milwaukee. So if you go 110 minus a 25, we would get 85. That's how many people were from Cudahy. So if we go 65 plus 85, then the total Cudahy people would be 150. So we could do 450 minus 150, that would give us 300 from South Milwaukee, and 300 minus 25 would give us 275. Just to check, 65 plus 275 does equal 340, so we're right.